Hi guys, Red here. Going to do a tutorial today on making the LLOAD LLOAD, otherwise known as the low latency open adapter for MiSTer FPGA, version 1.1 by Mr. Boot Sector. I'm going to turn off this light, it's a little bit much. So what we're going to do is we're going to look at everything that we need to do this. Let's just go through it. First thing you're going to need, obviously, is the PCB, which you can order from any number of Chinese PCB or American PCB or anywhere in the world PCB makers. You just upload the files provided by Boot Sector, and they will send this thing back to you in a matter of days or weeks. So that's the main thing you're going to need, and then there's all this stuff. This thing is actually not too complicated, but there are a number of parts that we will need. So I'm just going to identify each and every one of them. So these here, these are sockets for this, and these are for this here, and these are optional. These will allow you to change out the Arduinos should you need to. You can pop them in and out. Just an optional thing, but I think it's going to be useful for what we're doing here. Then onto the Arduinos. I'll have listed what exact Arduino you need, but here it is right here, and we're going to need to solder on these headers. Over here we've got our DB15s, two of them. These are the Male version. Those are going to be mounted right here. We've got our Schottke diodes, 1N5817. Right here we have our USB 3 connector that's going to go right here. We got our little voltage regulators. It's going to go right there. A capacitor right here in the circular spot. And then these various spots here are all for resistors, the 10K variety. Okay, so that pretty much covers everything that we're going to need to solder to this thing. Not too bad. In order to solder this, though, we're going to need a variety of tools. Let's see here. We're just going to go through them one by one. For any kind of electronics project, this thing's handy, very handy. You just test continuity or any other number of things. Got some Scotch tape for holding stuff down. Got some chem wipes for cleaning up. I've got a brush, anti-static brush for cleaning up right here. Very, very useful, especially for mounting SMD components. A nice fine tip tweezer. We're going to be using that for sure on this little guy right here, the voltage regulator. We've got our solder. I've got some no clean. Let's see if we can get some light on this thing. Some no clean solder flux. Flux is extremely important. We're going to use that. If we want to, we could use this paste flux. Paste is actually a little bit easier, so for your project, you may want to use paste flux. This stuff's pretty good too, but flux is essential. Do not skip flux, especially if you're a beginner. Solder has flux in its core, most of them, but it's helpful, very helpful to have more flux. This thing right here is my beat up old third hand. I may or may not use this thing. This thing right here, for safety, is a fume extractor. Pretty good idea to not let that resin that's going to burn off from your solder into your lungs, so this thing helps with that. Just to dispel any myths out there, when you burn solder, you're not the fumes that come off it are not the metal itself. It's the rosin flux that's inside the core of the solder. So, anyways, it's wood. It's made from wood, but it's still not something you want in your lungs. Okay, and then very importantly, we're gonna have our soldering iron. Mine is a FX 888D. Pretty decent soldering iron from Hacko. It's around $100 if you want one this nice. We're going to set it to, I believe we're going to set it to 675 F. Yeah, 675. That's what we're going to go with today. F for Americans. And then here's the tip we're going to use. Yeah. Energy drink, optional. More tweezers, should we need it? But we shouldn't. And I think that will about do it. And we're going to proceed from here on out. Alright, first up we have the Arduino. And there are two of them that you'll need to do, but I'm going to show you one. In order to get this thing ready, we're going to need to solder on two headers, one for each side. The small 2x3 6-pin header at the back of the Arduino, you don't need that, so just dispose of it or save it for later. So what you want to do is you want to put in both those two headers and get that thing as stable as you can. You're going to need both your hands to solder usually, so get it as stable as you can. Alright, so first up we're going to need to apply some no clean flux to all the areas we want to solder. And then we're just going to start soldering. And the way soldering works is the solder wants to flow to where the heat is. And in order for a joint to happen, you need to heat up both of the two things that you want to join. You want to heat up the metal from the pin in this case, and the small circular pad, and then you want to apply the solder. So you'll see me do that here. And you may notice what I'm doing first is I'm just doing one pin from each side, and that's a technique called tacking. And you're tacking down the first pin so that the piece is more stable for the rest of the soldering. So again, apply heat to both of the metal pieces that you want to join, and then bring in the solder from the other side of the iron. And you see I brought out that masking tape roll, and that's just to stabilize it, just so that this thing doesn't move around as I'm applying the solder. You have a bunch of these pins to do. Just take your time. Heat up one side, both pieces of metal, apply your solder. Keep that up and you'll be done in no time. You can see my right hand has the iron, my left has the fine solder. I just feed that in as I need it. You may find that your iron, after a while, gets too much solder on it. That's the time to go back and clean it off using your brass cleaner. It's kind of like a metal sponge or metal scrubby. Just go in there and clean off the excess solder. And you can see after I do all the headers on one side, I kind of inspect it and then go back in and just apply heat to the two joints for each pin, just to make sure there's a good solid clean joint. Now onto the other side. Find yourself in a sticky situation where your piece is moving all around, just stop, reposition it, try to get comfortable. You can see my hand shaking here a little bit. That's okay. Once you set the iron down, you'll be stabilized. Just put it down on the place that needs to be heated. The two sides will heat up and the solder will flow. Solder, flux, and heat equals a good joint. You see here I move my fume extractor because I don't want to breathe in all those all the flux fumes from the flux burning off. As you do these joints, the flux is getting consumed. Now, if this all seems a little basic, that's because it is. This is not a terribly complex or terribly difficult solder job, but that's okay. This video is intended to help people that maybe have never done this before, or haven't done it in a long time, or maybe they tried it and they had a really hard time. I'm by no means an expert. I'm not a professional or anything like that, but I've done this enough that I'm feeling a little more comfortable with it, and I hope that this helps you. Okay, the Arduino's done. Remember, you don't need that 6-pin header there. You just can get rid of that or save it for another project. Now, it's time to move on to our main PCB. First up for that will be the sockets. If you look at these sockets, at least the ones I got, you'll notice that there are 2 extra pins. It's a little bit too long, but that's no problem. You just need to remove 2 of the pins from one end and it should fit right in there. If you take a close look at the PCB, you'll notice that there are actually on each of the 4 corners some pads that have no metal. Those are just anchoring or positioning pins. Nothing is going to get soldered in there, so just keep that in mind. So this is what those sockets are going to look like once they're soldered on. It's always a good idea to do a dry run before you actually solder. Notice they're a little bit too long on the back end there. Well, I've cut off a pin. Okay, notice when I put this down that I've got both sockets in place, and the reason I did that is for stability. You want that thing to lay as nicely as it can be before you begin soldering. So get it just right before you even think about soldering, and then you'll be good to go once you actually do. Alright, that looks good. We're ready to solder. First up, a little more no-clean flux. You can do this without the no-clean, but it is definitely easier to use the flux there whenever you can. You can see I only did those 4 corners because I had the intention of tacking it down. If you only do those few points first and something goes wrong, you can get that solder up and reposition if you need to. So do those 4 corners, make sure everything still looks good, and then do the rest of the pins. Now if you're having any trouble at all getting your joints to form between the 2 metal things that you're trying to solder together, you might want to do something called tinning the tip of your iron. And basically what that is just adding a little bit of solder directly to the iron itself. Once you have a little bit of molten metal on the tip of your iron, it helps to transmit the heat between the 2 things that you're trying to join a little more effectively. So you might want to clean off your tip every now and again. When you go back to work again, just put a little bit of solder on there. Tin that tip up, and you'll have a better time of it. Okay. Inspect our work. Both sockets are flush up against the PCB. It's time to do the rest of the pins. Let's apply some more liquid, no clean flux to all of the pins, and then we're going to solder. Take your time. Bring the iron to the two metal pieces you want to connect. Heat them both up. Add solder, and you got a good joint. Now take a close look right here. Something has happened. You see that big blob of solder joining two pins? That's called a bridge. You don't want that. Fortunately, it's pretty easy to take care of those usually. What you want to do is just clean off the tip of your iron and come back in and just drag that iron between the two pins that have that solder bridge. And usually what will happen is the heat will just cause everything to even out. The solder will go onto the two pins themselves, and some of it might come back onto the iron. In any case, you're going to clear that bridge out real quick. Don't stress out if that happens to you. If you do find yourself in a mess, where there's just a ton of solder and there's a lot of bridges, there is a solution. There's this fairly inexpensive product called solder braid. And what that is it's a bunch of fine strands of braided copper with flux in it. And you just put that down on top of your bridging and apply heat to it and the joints. And usually what happens is the capillary action will suck all that liquid molten solder back up into the solder braid itself. And you can just dispose of that solder braid that's all infused with a whole bunch of solder. Just cut that part off of your braid and you're good to go. Time for some more liquid, no clean flux. Don't forget the flux. Flux will make things easier. One more set of pins and we'll be done with our sockets. Maybe these joints could flow a little easier. Let's not forget to tin our iron. There's a lot of pins, but you can go pretty fast once you get going. Remember, we're trying to form these conical filleted shapes here. You shouldn't see any space in between the pin and the hole. Should be nicely filled in, not too much solder, but it should have a nice cone shape. We're making lots of small, tapered cones. If you got a big blob, touch the iron back on that pin and it'll probably turn into a nice cone. Alright, inspect your work. Make sure you got all those nice cones. Everything's copacetic. Something's not quite right, come back in, add a little bit of solder. Maybe just touch the iron to a pin. Get everything nice and smooth and uniform if you can. Okay, all done. Time for the final inspection. Next up is probably going to be the most challenging component we're going to solder on here, our little voltage regulator. This is called a surface mount component, and it can be a little intimidating, but let me show you how to do it. It's not so bad. Now you're going to see me futz around with this thing, using my tweezers, using my hands. Remember, dry run first. Get an idea of how it's going to look when it's soldered before you actually solder it. Okay, what's first? That's right, flux. Both pad sides. You got 3 little pads and 1 big pad. So our strategy is this. We want to get a little bit of solder on each one of those 4 pads. So we're going to come in with our iron, heat up the pad first, then apply some solder, forming a nice little mound of solder on there. We're going to do that for each of those 4 pads. There, that looks good. Now it's just time to position our little voltage regulator into its proper place. This could take some time, but you don't want to rush this. So what we're going to do is we're going to place this voltage regulator down on top of those solder blobs that we made. Yep, a little more flux. Flux can't hurt. Put it right on the component. So what we're going to do is we're going to get this thing to position, and then we're going to kind of hold it there with either the tweezer or, in my case, my finger. And then we're going to make one pad side molten with the component on top of the pad, and the solder will come up around and onto the component tab, and we'll have a joint. Once we've got one joint, it's easy to make the other 3. So we're going to do the big joint first. Careful. Easy does it. Okay. Let's bring in the soldering iron. Oh, maybe not. Don't get nervous. You got plenty of time. There we go. Heat up the metal, heat up the pad, boom, it's connected. It's a little crooked, that's okay. Take your tweezers, reapply the iron to the solder side, get things moving, shift it a little bit, that's better. Hold it down with your tweezer, get a nice shiny joint. Now just apply the soldering tip to the 3 smaller tabs, and we've got a good connection. Thanks to that flux and the way solder wants to flow towards the heat, just put that iron down on those small tabs. The solder will come up and form a real nice, filleted, solid joint. Okay, next up is our USB 3 connector. And these things are real neat. They have the 9 pins, but then they have these 2 extra bracing pins that don't actually do anything electrically. And what they are is they just make it a really strong physical connection. They provide stress relief. That's what those 2 things, those 2 large ones on the sides are. But we'll do those last. We'll do our connecting pins first, and then those stress relieving pins last. Don't forget the flux. Same concept as soldering in our socket. They're a little tighter together, but just come from one side with your iron and solder on the other side, and you'll have no problem here either. That's right, tin the tip, get things flowing. Easy does it, you got this. If you have a bridge, you know what to do. Just touch the pins back and forth with the hot iron. They should sort themselves out. Clean off your tip if you have too much solder, and just keep going. you need to take a break, take a break. There's no rush here. Once you got those joints in place, come back in for a final pass with the iron. Make sure you got those nice cones, and you're all done. Alright, that's the connecting pins themselves for the USB 3, 9 of them. Now it's time to do our big bracing pins. Now these are going to eat a lot of solder, but that's okay. You want a real strong connector, a strong physical connector. If you're going to be plugging a USB 3 cable into this thing a lot, you want it to be strong. So just fill these big holes up until you can't see through them anymore. There should be a good amount of solder on. It is possible to get too much. You flip that thing over. If you see solder starting to come through on the other side a lot, then you know you got plenty. That's all there is to it for that one. Quick and easy. Alright, next up we got 2 DB15 connectors to do. And these are very similar to the USB 3 one that we just did. Only easier because they're bigger. There's a little more space in between the pins. There's an even bigger set of bracing holes on the left and the right of each one of them. That's the same concept. Don't forget your flux. Come in, iron on one side, solder on the other. Both metal surfaces connected with molten solder, solid joints, tapered cones. Now, just like with the USB 3 anchor pins, these DB15 anchor pins are going to take a lot of solder to fill in, but you definitely do not want to skimp on these. Be sure that plenty of solder goes in there and fills up that hole completely, and maybe even then some. These DB15 connectors are going to be some of the most heavily used, mechanically used parts of this device, so you want it to be extremely strong. And so don't skimp, put plenty of solder in there and you'll be good to go. Okay, second DB15 connector, pop it right in and get to work. Now, there's something I want to mention here, and that is, if you spend a lot of time on a joint, like maybe too much time on a joint, you can actually burn through all your flux. And what will happen is you'll form what's called a cold connection. The solder will begin to oxidize. It will no longer form a strong, solid bond with the two metal surfaces. It'll be brittle and it'll be prone to failure. So ideally, you just don't want to spend too much time. You don't want to burn through all your flux before you're done soldering. But if you do, if you find that your connections are starting to look dull instead of shiny, just make sure you add some more of that flux to your area. The no clean flux especially burns out very quickly, so keep the area nice and covered with flux throughout the entire process. And you see this right here? Formed a ball. Oh, just touch it back with your tip. Make it a cone. You don't want those balls. That's not a strong joint. Alright, looks good. Let's fill in those big anchor holes. Alright, it's time for our last few components, and they should be real easy. First up, 10K resistors. 7 of them. Now there's a trick to these. They're not too hard at all, but what you want to do is kind of take them off the thing they came in and form it into a U shape, such that it will fit into the two holes. It doesn't matter which side goes where. These are not polarized, so just stick whatever side you want in to whatever side. And yeah, form that U shape, stick them through the two through holes, and then flip the board over. The reason you want to flip the board over is because it'll just fall out if you were to leave it like this. But if you bend the two leads down like that, it'll stay put. It'll stay put long enough for you to solder it. So take your resistor, form it into a U, stick it through the two through holes, flip over your board, bend down the two leads, and then flux. And then it's time to solder. Tin your iron, bring it to the two metal surfaces you want to connect, in this case the lead and the circular pad on the PCB. Feed it some solder and you've got a nice little joint. These won't take much solder at all. 1 down, 6 to go. What do you say we speed these up? Go ahead and slow down the video if you need to, but this is just more of the same. After you're done soldering these guys, it's time to take your wire cutters. Just cut off that excess. Careful, those things can get flying and you don't want one in your eye. So wear eye protection, or at least cover it with your hand when you cut it. Okay, all the resistors are soldered in there, all the excess leads are snipped off, and we've just got 3 components left to install, and then we're all done. Alright, up next, 2 Schottke diodes. And diodes are very similar to resistors in the way that you solder them, the way that you install them, but there is one thing you need to pay attention to, and that is that they are polarized. And what does that mean? That means that one lead has to go in one hole and the other lead has to go in the other hole, and there's no reversing it, otherwise it's not going to work. So if you look at Boot's diagram on in the PCB, you can see there one end of the diagram has a little bar on the end of the diode. Well, your diode that you have will also have a bar. So just match those up and you'll be fine. Same procedure here. Bend the leads into a U, stick them through the holes, flip the board over, and then splay out the legs, the leads, so that there's some tension. Get to soldering, flux first, and you're good to go. Alright, final component. That's our capacitor. And capacitors are similar to diodes in that they are polarized. What does that mean? That means you can only put them in one way or else it's not going to work. And in the case of a capacitor, one side of it will have a stripe and usually a minus sign. And that will also be the short leg of the capacitor. If you look on Boot's diagram, you'll see there's a circle, and one side has a plus, and the other side doesn't have anything. The positive side of the capacitor, the one with the long leg, goes in the hole that's indicated with a plus. Short side goes in the hole that's not marked. One final tinning of our tip, and we'll finish the capacitor and be done soldering. Well, alright, we're all done soldering. We did it. That wasn't so bad, was it? Anytime you finish up soldering, you definitely want to clean up your mess. All that flux that was so useful for soldering, well, it leaves behind a sticky residue, and we want to take care of that. So the way to do that is to take some isopropyl alcohol. I use 99%. Higher content alcohol, the better. Just apply liberally to the flux covered areas and do some gentle scrubbing with a nice anti-static brush or an old toothbrush if you don't have one of these. It's not hard, it just takes a little time. Don't go too hard, you can damage things if you do. But try to clean it up as best you can. And then after you're done with the alcohol, take your Kim wipes and clean up any of the little excess, and you should be good to go. All done. Alright, our final step is to insert our programmed, fully assembled Arduinos into their respective sockets. And that's pretty easy to do, but you do want to be careful. Remember, the top 1 and the bottom 2 pinholes are not active, so carefully insert your Arduino into the correct pinholes and you'll be good to go. Alright, all done. Thanks for watching. I hope this helped. Take care.